This is Stud, and he is my attempt of making a fully functioning robotic dog out of Lego. Using the EV3 robotic system, Stud is able to walk and run, detect and avoid obstacles, and even dance. I gotta say that this was a really hard project. While I was building and testing the model, it just didn't want to work, a bunch of parts broke, and overall this was way harder than I thought it would be. Before we start this video, I'm going to be giving away 3 months of YouTube Premium to a random viewer. All you need to do to enter is to make sure you're subscribed, like the video, and leave a comment down below. Now, let's get back into the video. Okay, so here's my plan. I'm going to be using the LEGO Ev3 robotic system for this build. First, we have the main powered brick, which will go in the middle. Then I'll attach a large motor to each of the sides, powering the front and rear legs. After that, I'll use a medium motor to control the steering. How I intend all this to work will be a lot easier to explain when I'm done the model, so let's start building. Okay, so I finished the test model by using some leg designs I found online. It walks quite well with the help of his support. Now let's see if it can walk on its own. The motor at the front of the model was way too heavy for the front legs to support its weight. I tried to fix this problem, however, I failed. This time, I created my own leg design. It's way stronger and it looks way better than the previous version. Here, I am testing the steering. Unfortunately, it didn't work well because the joints were too loose. These are the new and improved joints used to attach the legs to the steering. I finished most of the parts for the main body of this build, and here is the new and improved steering mechanism. It works way better and it's also way stronger. Now it's time to attach everything to the main powered brick. I'm using a long axle to attach the medium motor to the steering system. The reason the motor is so far away is so that both sides are balanced. These are the cables to connect the motors with the powered brick. Now we're adding a few support beams to make everything stronger. The body for the robotic dog is now done. I've changed the colors for some of the parts, and I've also added a few more details such as this infrared sensor at the front. Now it's finally time to add the legs. With all the legs in place, the model is finally done. Now that I've finished building the robotic dog, all I need to do is program it. In the meantime, I'll show you how it works. As you already know, the 4 legs are powered by 2 large motors, one powering the front legs and one powering the rear legs. The front and rear legs are offset by 180 degrees, and so are the legs on the left side and right side. This creates a smooth walking motion, similar to how a cat or dog would walk. The steering mechanism is controlled by this medium motor up here at the front. It's connected to this long axle, which is connected to a gear, which then moves the gear rack, causing the steering mechanism to work. Using these universal joints over here, the legs are able to move while the model is steering. Unfortunately, there is a slight flaw to my steering mechanism. You see, when a real vehicle steers, the inner wheel travels a shorter distance than the outer wheel. Therefore, it needs to have a higher degree of rotation. Unfortunately, I couldn't get this to work on my model. But who cares? It doesn't even really matter. It's time for the moment of truth. I made a simple program that makes Stud walk forward. Let's see if it works. Turns out the legs weren't positioned properly. Let's try that again. Please tell me that was a fluke. I hate this thing. No matter what I did, it just wouldn't work. But eventually, after all the failures, I finally found the solution. Right now, when a robotic dog is walking, the front and rear legs are offset by 180 degrees, meaning at least 2 legs will be touching the ground at all times. However, if we delay the rear legs by a tiny bit more, then each step will be taken separately, meaning that at least 3 legs will be touching the ground at all times, and balancing on 3 legs is way more stable than 2 legs. After all the testing and failures, Stud is finally able to walk forward without any problems. Due to stability issues, walking backwards requires a slight pause between each step, but after all the work I've already done, I'm way too lazy to fix this. Now that Stud has mastered walking normally, let's make it steer. Remember when I poorly designed the steering mechanism earlier because I was lazy? Well, I probably should have done it properly because right now when the model steers, the legs slip and it falls over. Fortunately, I was able to solve this problem by adding some of these rubber pieces to the bottom of the feet. At first, the model had a really small turning radius. However, after a bit of tinkering with the mechanism and testing, I was able to get a turning radius that I was happy with. Now that I have all the individual parts working, I just need to put everything together by writing out a few programs.
A few moments later.
To make things easier for me, I switched over to a much more simple programming software. It's not as powerful as Python, but it's way easier to use. After a bit more time, I was able to create a few more programs for the robotic dog. The first one allows the user to manually control the model via remote. I also made a few more programs for fun, such as the short dance sequence, or this amazing obstacle avoidance program, where the model walks around avoiding any obstacles in its way. At max speed, Stud is able to travel at an impressive 1.8 kilometers per hour. After all the work I've done, Stud finally works perfectly. I gotta say that I am really happy with how this model turned out. Making a 4-leg quadruped isn't easy, especially if it's out of LEGO. If you don't believe me, try and make one yourself. In the future, I might come back to this model and make even more improvements. I could add a wider range of motion, maybe add a robotic arm, or I could even make it do this.